The purpose of this video is to show how to multiply binomials. And on the first page here, we're going to take a look at a model sort of physical way to do this and to help explain why you do what you do. And then on the second page, there are 4 examples that go from a fairly basic multiplying 2 binomials to something a little bit more complex. So that's the whole layout for the whole lesson. And so we're going to start with multiplying 3x by 2x. And so that's what this rectangle is for up here. And so the idea behind this physical model is really just find the area of a rectangle. And so this dimension here will be 3x. Now each of these diagrams are meant to be x long by 1 unit wide. 1 times x is 1x. So each of these has an area of x, 1x. The idea is that we're modeling the length of this dimension as 3x because there's 3 x's in length. And then we'll put 2 x's across the top here. 2 1x's is 2x. And so what we're looking for is the area of this rectangle. And so when we fill that all in, there's 6 of these, well, rectangles. They're actually supposed to be squares, so it depends on the device you're looking at this on or the resolution of your monitor. They might not look exactly like a square, but this rectangle is supposed to be x by x. So the 2 dimensions are the same length, so that's why it's supposed to be a square. So this rectangle that's x by x, or square, it would have an area of x squared. Now, what x squared means is an x multiplied by an x. So instead of writing x times another x, like this, we normally write that as x squared. X squared simply means 2 x's multiplied. Not 2 x's added. 2 x's added is just 2x. X squared means 2 x's multiplied because remember, for the area of a rectangle, it's length times width, and the length and width are both x here, so that's why that area would be an x squared. And of course, these are all the same, so they're all x squared as well. Notice that there are 6 of them. So the area of this rectangle that's 3x by 2x is 6x squared because there are 6 of those. So 3x times 2x should be 6x squared. What you're actually doing algebraically is going 3 times 2 is 6, and then x times x is x squared. You're actually adding the exponents. There's actually a 1 here you don't see because x means x to the first, and a 1 here. 1 and 1 adds to 2. So that just simply tells you that there are 2 x's multiplied there. So 3x times 2x is 6x squared. Now we can also use these rectangles, they're called algebra tiles when you physically have them, to model something like multiplying 2 binomials. So we're going to multiply using this one, x plus 3 by 2x plus 1. And so on the left here, this dimension here would be, this is x, and then each of these little tiny squares is supposed to be a 1 by 1 square, so they have an area of 1, or each dimension's 1. And so this would be x along here plus this 3. So that side would be x plus 3. Now we're multiplying it by 2x plus 1, so the dimension across the top would be 2 of these x's, and then plus 1 in the very end. So 1x plus another 1x plus 1 is 2x plus 1. Now when we find the area of this rectangle that's 2x plus 1 here, by x plus 3 here, then these are all the shapes, squares, rectangles we get in the middle. Now, when we do this, okay, so each of these are an x by x dimension. So these are x squareds, just like those are all x squareds. This dimension right here is x. This dimension is 1. 1 times x is x. So that's an x. That has an area of x. Each of these down here are the same size. So each of them is a dimension of 1 for width and x for length. 1 times x is x. And then this would be an area of 3 down here to fill out the rest of the thing. Now, what I want to do is draw connections between when we do this algebraically and the physical model over here. So if you multiply x by 2x, you get 2x squareds. There's 2 of these x squareds here. 1 in front of the 1x times 2 in front of the 2x. 1 times 2 is 2, and x times x gives you x squared. So that's that area there. This is actually the area of a rectangle that's x in this dimension by 2x in this dimension, because that's what we multiply to get the 2x squared, x by 2x. And so you get 2x squareds. Next, I multiply x by the 1 over here. And so 1 times x is x. And so that's this area right here. It's x in this dimension by 1 in this dimension. So now there's something called FOIL I'm going to talk about in a moment too. But basically, when I multiply binomials, what I'm always doing, and this is good because this idea extends to multiplying larger things together too, is multiply everything in one polynomial by everything in the other. So I've noticed I've taken the x and multiplied it by both terms over here. So I finished with the x. Now I'll turn my attention to the 3 and multiply it by each of the terms over here. So I'm going to do this next. 3 times the 2x would be 6x. And the model here, that actually comes from multiplying 3 by 2x. So that's actually the two dimensions that were multiplied there. And notice it gives you 6 x's. And now we'll multiply the 3 by the 1 over here. 3 times 1 is 3. And so that actually is this little bit here. 3 times 1 is 3. So that's that area there. So notice that these are actually all the areas that make up this whole rectangle here. Now you often have like terms, not always, but often. And so there's a 1x and a 6x here. 1x and 6x would be 7x. So we can combine those together to call it 7x. The 3 in the end and the 2x squared at the beginning, they don't have any like terms to combine with them, so that's the final answer. Now this idea of FOIL, here's another way to remember how to multiply binomials and not forget anything, basically. And so when you multiply the first term in the first binomial by the first term in the second, that's the F in the word FOIL, or acronym FOIL. First term times first term. The O in FOIL stands for multiplying the outer terms, which is the terms that are basically the furthest apart. So the first term in the first binomial by the second term in the second binomial. The I stands for multiplying the inner terms, which are the terms that are the closest together physically. The second in the first binomial and the first in the second binomial. So 3 times 2x is a 6x. And the L stands for multiplying the last terms together, which would be the 3 in this one and the 1 in this one. And so that's the L part. So FOIL is just an acronym to help you remember all the parts to multiply, basically. It does exactly the same thing as what my arrows did here. So, 4 examples on this page. In A and B, we're going to start with just multiplying two binomials together. So first of all, x plus 5 times x plus 3. So I would begin by multiplying x by x, which is x squared. And then I will multiply the x by the 3, which would be 3x. And then 5 by the x, which would be a 5x. And then 5 times 3 in the end will give you 15. 3x and 5x are the only like terms, so they would add to give you 8x. So the final answer is x squared plus 8x plus 15. If we go back to FOIL once here, the F stands for multiplying the first terms, which is the x times x. The O stands for multiplying the outer terms, which are the x and the 3. The I stands for multiplying the inner terms, which is the 5 and the x, the two that are closest together. And the L in the end is multiplying the last term by the last term, which gives you the 15. On to B, 3x times 4x. I'll do the arrows one more time here. 3x times 4x is 12x squared. 3 times 4 is 12. Remember, x times x is an x squared. And then I'll multiply the 3x by the 1, which would be a 3x. And then negative 5 times 4x, which would be minus 20x. And lastly, which is the L in FOIL, the negative 5 times the 1, which would be a minus 5. And once again, the like terms are the two in the middle. 3x minus 20x is negative 17x, because 3 minus 20 is negative 17. And so we get 12x squared minus 17x minus 5 for our final answer. That's as simplified as that can go. These are all different kinds of terms now. No x here at all. It's called a constant. And x to the first and x to the second, different variable parts, so the different kinds of terms. Now in C, we're going to extend this a little bit because we've got basically two binomials, and they're multiplied by this -2 here. Now there's more than one way to do this. What I'm going to do here is leave the -2 alone, multiply the binomials, and then after that's done, then multiply the -2 in. So that's one way you could do this. So that's why I'm going to start by just writing -2 in brackets. So I'm going to multiply these together. So f from FOIL, so first terms, first 3x times 5x would be 15x squared. The O is the outer terms, the 3x by the 6, which is 18x. Then we multiply the inner terms together. -4 times 5x would be minus 20x. And the last terms, -4 times 6 would be a minus 24. And then let's collect the like terms. See, these are like terms. 18x minus 20x would be -2x. So everything else is the same in here except that's -2x. And then we'll multiply the -2 in. So we're going to distribute the -2 in, and it just gets multiplied by all the terms. So -2 times 15x squared would be -30x squared. -2 times -2x would be a plus 4x. And -2 times -24 is positive 48. And so there's a final answer. Now, another way you could do this is we could multiply the -2 in first, like this. You only multiply it by 1. If I were to multiply that by the 3x minus 4 and also again by the 5x plus 6, I've actually changed the question, because then I'm actually multiplying it by -2 twice. There's only one single -2 here, so you don't multiply it by this and also this. Just like if somebody told you to do 2 times 3 times 4. You wouldn't say 2 times 3 is 6 times, and then again multiply the 2 by the 4 and say that's 8, so the product's 48. Okay, so that is not the correct way to do that. That's not true. See, 2 times 3 is 6, but it's still just 6 times the 4 in the end. So the answer should be 24. So notice by multiplying by that 2 a second time, you're not supposed to, then your final answer is actually twice as big as what it should be. Okay, so you only multiply it in once. So if I multiply the -2 by the 3x minus 4, I would have -6x at the beginning here. And then -2 times -4 would be plus 8. And so we have to multiply that by the 5x plus 6. And just to demonstrate that this does work out correctly, see, -6 times 6x times -5x does give you this. Now, the middle terms, okay, so this would be a -36x. And this would be a 40x when you multiply the 8 by the 5x. And you see -36x and 40x do add to 4x. And then 8 times 6 on the end does give you 48. So it does work out to be exactly the same product. So one last example in D here. We're going to just something a little bit bigger, just as one more example to extend this a little bit. So this is kind of like the what we did in C, and then minus another binomial product in the end. So you have to keep in mind BEDMAS when you're doing this. You have to do all the multiplying before you can add and subtract like terms. So I'm going to, very similar to C, start with just writing the 3 down and multiply the two binomials together. So 2x times x would be 2x squared. And then 2x times the 7 would be a 14x. I finished multiplying the 2x in here, so now I'm going to do the -1. -1 times x would be a minus 1x. And -1 times the 7 would be minus 7. Close the bracket. And then minus. And so, well, let's go back to FOIL for a moment. The first terms, which is the 5x times x, would be 5x squared. The O is next, so the outer terms. 5x times 3 would be a 15x. The inner terms, -1 times x, would be a minus x. And the last terms, -1 times 3, is a minus 3 in the very end. So now I can multiply my 3 in here. Well, actually, let's combine like terms and then multiply it in. 14x minus 1x would be a 13x. So 2x squared at the beginning, 13x minus 7. And then there's actually like terms here too. 15x minus 1x would be a 14x. So now I'm going to multiply the 3 in. And 3 times 2x squared would be 6x squared. 3 times 13x would be 39x. And 3 times minus 7 would be negative 21. There's really a negative 1 here. And so it's really like multiplying a negative 1 in by all these, and that's why all the signs change. So negative 1 times 5x squared is minus 5x squared. Negative 1 times 14x is minus 14x. And negative 1 times negative 3 is plus 3. Okay, so now we have some like terms. 6x squared minus 5x squared would be x squared, so a 1x squared at the beginning. And then 39x minus 14x would be a 25x. And negative 21 plus 3 is minus 18. So that's what that would simplify to. And that's the end of the lesson.